in this case the slope is 2, so this ramp is presented by 2 RT, and in this case if the ramp is shifted in the time second t is equal to 2, so slope should be maintained. Here 2 RT minus 2 can be presented in that fashion. Here 2 indicates that the slope, so already we can determine this is this magnitude is 2, this magnitude is 3 minus 2 is 1, so the slope would be 2, and as this signal has been shifted to t is equal to 2 seconds, so ultimate signal representation would be 2 RT minus 2. This is very familiar to you, so I think it is being difficult to you. I will request you to watch or to observe or to study again. So if we want to sum up two signal like that, once one ramp is in t is equal to 1 second and in t is equal to 2 second, like that. So this is the 2 RT minus 1. If you compare this and that, you can easily understand that. So this is the 2 RT minus 2 because the slope is negative, so we can present minus 2 RT minus 2 in this fashion. So after summing up two signal, what would be the ultimate fashion? So actually I have discussed already, if we sum up two ramp signal, the ultimate signal would be that. Why this fashion would be arisen? Because the slope of this signal, ramp signal, is positive. This slope of this ramp signal is negative, and most important thing is although their slope is one for positive and negative, however slope is magnitude is same. Here 2, in this case also 2. So in this way, if we add two signals, then after adding up of them, we actually get the signal like that. Okay, this would be very important in our next classes or next lectures. So actually in this video I am trying to present some basics. So if we add a minus unit unit step like that means minus 2 t minus 2, it is very familiar to you. So in this case, if we add this signal with that a negative unit step, so what would be the ultimate signal? This fashion would be arisen, and this signal we will get after adding up a negative unit step. So by this way we can add the triangular or ramp, or several wave shaping can be found. So what would be the step-by-step differentiation result if we try? So here I want to mention that if you differentiate the ramp signal, you will get the unit step. If you differentiate the unit step, you will get the impulse. So it is very important for the next classes or next lecture. So I will request all of you to understand or to what should I say, you need to practice several times. So what I am saying that if you differentiate ramp signal, you will get the unit step. If you differentiate unit step, you will get the impulse function. In reverse process, if you integrate the unit impulse, you will get the unit step. If you integrate unit step, you will get the ramp. So this sequence must be what should I say, the memorize or practice and something like that. So in this case actually here some sort of singular function actually contained here, as I have discussed in that cases. So what would be if you are given that xt is like that, so what would be the differentiate of the xt? Actually if you integrate this is a ramp function, so after differentiating a ramp you will get unit step, not the and if you, in this case you may ask that this is not a ramp and this is not a unit step. How those are similar? Because there is a part here, a ramp, and actually that portion indicate the ramp and that portion indicate the unit step. So this portion are actually being derivated from that. Okay, so in this fashion, if you are asked to differentiate that, you can simply get the differentiate of that xt is like that. So triangular or a ramp signal, after differentiating that, you will get the that signal actually. However, in that case, the most important thing I need to mention here, the slope was positive here. In this case, the slope was positive. So our derivative or the final result was in positive axis. However, in this case also our our slope is positive. So our after derivating the signal, we got the derivative in positive axis. However, if we have a negative slope, we actually get the unit step in the negative axis, and in similar way, if we have another negative slope, we will get the derivative in the negative side. So basically, I try to explain what would be the derivative of some particular cases. So again, I'm requesting all of you that if you try to do better in Fourier transform like signaling, you need to memorize or practice these things like that. If you differentiate the ramp signal, you will get the unity step. If you differentiate the unity step, you will get the impulse. So in 4 cases, actually these 4 scenarios suggested that you just differentiate the xt to get the derivative of themselves. And now if we think that we are given unity step function and you need to differentiate that, and these are the cases. So if you have to determine the derivative of this unity step function, then you will get a impulse in at that point, also here at that point. However, in this case the value was rising, so the impulse would be like in that fashion. Here lowering the the value is degrading here, so these impulse actually should be written in that fashion. So I hope you understand the case. So in that case, you can differentiate with that. So if you have to differentiate this xt and you need to determine the signal, just have a close look on it. You can see that this is the negative direction, so our impulse is in the negative direction. This is the upper direction, so our the direction of impulse is here at that point is upwards. So basically in this fashion we can determine the derivative of a given signal. And the most important thing, if you have to determine the ramp, you will get the unity step. If you have to determine the derivative of a unity step, you will get the impulse. So I will request all of you to practice these fashions. And thanks for watching these videos, and in next video I will discuss the another content actually.